Okay, I want to show you how to fill a Klein bottle. Can a Klein bottle be filled? Does a Klein bottle have volume? You ask a mathematician and they'll say, well, a Klein bottle doesn't really have any volume. It's a topological shape. This doesn't have volume, but wait a second, it looks like it has volume. Well, if you ask a topologist, does a measuring cup have volume? They'll probably tell you no. Does a sphere have volume? Yep, no matter how, 4 pi r cubed, whatever, it has a volume. It divides the universe into an outside and an inside. And no matter how you stretch and contort it, if you shrink it, if you make it bigger, it'll always have a volume. Well, a piece of paper, I can make it into sort of a cup somehow or another, but it'll always occupy very little volume, or in the limit none. Likewise, a bag. Right, I can put stuff into it. I can even put stuff that has volume into it, but
it doesn't divide the universe.
It doesn't divide the universe into two parts. If I were in outer space, all of these grapes would float out. A bag doesn't divide our universe into two parts. This is related closely to a two-dimensional problem called the Jordan curve problem, which asks a cool question of, is there a difference between that curve and this other curve? This encloses an area. This doesn't enclose an area. Turns out to be a surprisingly difficult thing to prove. And the mathematician Camille Jordan, who finally solved it, was a real smart character. In the same way, to a topologist, the question is, does something divide the universe into the outside and the inside? A Klein bottle? Even a three-dimensional Klein bottle, an immersion like this, well, the air on the inside of it can easily escape to the outside. Sort of. And this cup, this measuring cup, which says, oh, 500 milliliters over here, a physical volume, to a topologist, they just melt it down, flatten it out, and say, oh, this is homeomorphic to a disk. It has no volume. A disk has no volume. So be careful when you talk to mathematicians in the kitchen. Don't let them near your recipe book. Having said that, a sphere has a volume. A donut, a torus has a volume. But a Klein bottle doesn't have a mathematical volume. Got that. What about a physical volume? Well, this obviously, you can put, in America, it's possible to put 16 ounces of water in it. Everywhere else in the world, you could put 500 milliliters into it. Got that. So if a Klein bottle doesn't have a mathematical volume, does it have a physical volume? Well, the way I make these, the answer is, well, sort of yes. You can fill a Klein bottle with water and throw some dye in it also.
You can't pour that out?
Well, yeah, I can pour it out. Let's pour some water out. Go through here, glug, glug, glug. Pour it out. Out it goes, drop by drop. Essentially, it's vapor locked. It won't. So, yep, I can get water in, I can get water out.
So like the measuring cup, your Klein bottle in the real world only has volume depending on its orientation in gravity.
That's right. Another way of thinking of it is this measuring cup depends on gravity to hold water. In the absence of gravity, or if the gravitational field is inverted, hey, it doesn't hold water anymore. I got that. Likewise, a Klein bottle. But a sphere, hey, this is, if you put water in here, it'll stay in there no matter what. So, how do you fill a Klein bottle? Well, step one, for me, I'll put a drop of food coloring in. Boop. which is way more than you need. And a little bit of water in, a few drops. It'll go right through. Notice my fingers have already been dyed. So, okay, I got some water in there. Problem is, every time I pour water in, it vapor locks, and I only get sort of this much water in. So, come on over, I'll dunk it underwater and show you how to fill a Klein bottle with water, along with a little bit of blue in it. Dunk it underwater and wiggle it around each time a bubble of air comes out. And with each bubble of air, a little bit of water comes in. Let's get a bubble of air. And held underwater long enough.
So you're doing like a sort of a 360, are you, to get the bubble out?
Yeah.
Oh.
And if each bubble is about a milliliter or two, eventually, with each bubble leaving, conservation of something tells me that a bubble-sized bit of water is going in.
Still pretty slow.
Oh, come on, it's not slow. This is fast compared to the age of the universe. This is speedy compared to even something as rapid as global warming. This is fast stuff here. Not just fast, but, you know, compared to the rate it takes to make a Klein bottle, it's enormously fast. You could use an aquarium pump, you could use a water pump and so on, but here's a Klein bottle that's completely filled with water. And if I lift it up, at first it'll... Notice now when I take my hand off the bottom, a little bit dribbles out, but not too much. Can you put water in a Klein bottle? You betcha, in our physical universe. Problem, of course, is, you know, water can also be taken out. The real problem, though, is this. Once you get water in there, yeah, you can get almost all of it out by tilting it and sort of doing the opposite of what you did before. Tilt and pour, tilt and dribble out. Yeah, that works. So you get water in, you kind of shake it out. The problem is the last few drops of water. Oh, there's not much air circulation inside of a physical Klein bottle. As a result, the last few drops of water that surface tension holds there, do I have an example? Probably not very visible on the video, but there's droplets of water in here.
I can see that, yeah.
You can.
Yeah.
Well, getting the last few drops out means overcoming surface tension. Hard to do. So, to remove the last few drops, I'll let this sit in a dish drain for, an hour or three. A little bit of water will collect there. I'll pour it out. Then, to, get it nice and dry on the outside, the little bit of water still in there, I'll either pour acetone in, swish it around, pour it out, and then let the acetone evaporate. Pour alcohol in, that'll work, or intubate it with an aquarium air pump and pump air through it, let the water evaporate. This. And he says, isn't this the same thing?
That's why you do the astronomy, after all. It's not going to make you rich. It's not going to make you famous. It's not going to get you girls. Didn't work for me. What it does do is it gets you closer in touch with the universe